Welcome to the WIONPodcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how scientists have identified the most vulnerable danger zone on Earth for potential impacts from interstellar objects like 3I Atlas, a wake-up call from the stars for our planet's future. It's a reminder that even distant wanderers from the stars can teach us how fragile our place in the cosmos truly is. 3I Atlas is the toast of the town ever since it was discovered on July 1st. It is only the third interstellar object noticed in the solar system. It recently passed its closest point to the Sun and is now on a trajectory towards Earth. However, it poses no threat to our planet and will pass us by at a safe distance. But what if it were to slam into Earth? Which parts would face its fury? Scientists have now determined the areas on Earth most at risk of being devastated by an interstellar visitor. According to a new study titled "The Distribution of Earth-Impacting Interstellar Objects," low latitudes near the equator face the greatest risk from an ISO. The Northern Hemisphere is also vulnerable to an impact, albeit not as much. Notably, 90% of the human population lives in this region of the planet, which means if an interstellar object were to crash into Earth, the majority of the population could be killed. It was first reported by Universe Today. The study states, "In this paper, we calculate the expected orbital elements, radiants, and velocities of Earth-impacting interstellar objects. Their calculations are based purely on interstellar objects that originate in M-stars, also known as red dwarfs. They are the most abundantly found stars in the Milky Way, hence most ISOs would be ejected from such solar systems," the authors wrote. They also deduced that most ISOs would likely come from two directions, the solar apex and the galactic plane. The former is the Sun's path through the Milky Way, while the latter is the flat, disc-shaped region that the Milky Way occupies. The galactic plane is also where we find the most stars. Also, the objects that threaten Earth more will move at much slower speeds because the Sun's gravity can preferentially capture such objects and shift them into Earth-crossing trajectories. This does not mean that objects racing through at fast speeds will miss us. The faster ISOs are more likely to arrive in the spring, as at this time the Earth is moving toward the solar apex. But we'll face those with a higher likelihood of frequent impacts in the winter, since at that time Earth is positioned in a place where the Sun is moving away from. While the authors stressed that their work is mostly about M-star kinematics, they admitted that the main points in their work likely apply to other kinematics. The salient features summarized in this section presumably also apply to different kinematics, perhaps to a muted or more distinct overall effect, the researchers write. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.